Hello, science fans. Bill Nye here. Have you ever wondered why a ball falls down instead of up? Or how a microwave heats your food? Or what makes a rainbow appear after a storm? The answer to all these questions, and so many more, is physics. Physics is the science that studies everything in the universe, from the tiniest particles you can't even see to the biggest galaxies millions of light years away. It's the rulebook for how everything works. It might sound complicated, but trust me, it's not just for people in lab coats. Physics is for everyone, because it's happening all around you, all the time. Understanding physics is like getting a backstage pass to the show of the universe. It helps you appreciate the world in a whole new way. When you play catch, you're using physics. When you ride a bicycle, you're a master of balance and motion. That's physics. Even when you're just sitting in a chair, forces like gravity are at work. Learning physics isn't about memorizing a bunch of strange words and complicated formulas. It's about developing a sense of curiosity and asking why and how. It's about looking at the ordinary world and seeing the extraordinary principles that govern it. It's a way of thinking that can change your perspective forever. Now, I know what some of you might be thinking. Physics is hard. It's all math and confusing theories. I hear you. It can feel that way sometimes. Our first tip is all about perspective. Before you dive into the deep end with complex equations and tiny details, take a moment to look at the big picture. What is the main idea of the topic you're studying? For example, if you're learning about Newton's laws of motion, don't start by memorizing F=ma. Instead, think about the core concept. Forces change how things move. That's it. An object will keep doing what it's doing unless something pushes or pulls on it. A bigger push will cause a bigger change. For every push, there's an equal push back. See? That's the whole idea in a nutshell. Think of it like looking at a map before you start a road trip. You wouldn't begin by studying every single street name in a city you're going to visit. First, you'd look at the whole country or state to see where the city is located. You'd find the major highways that lead there. This overview gives you context. It helps you understand where you are and where you're going. In physics, the big picture is the fundamental principle. Once you grasp that main idea, all the smaller details and formulas will have a place to fit. Every formula, every definition, every example problem. It creates a logical structure in your mind, making it much easier to remember and apply what you've learned. So how do you do this? Before you read a chapter in a textbook, read the introduction. Read the summary first. Look at the section headings. Ask yourself, what is the story this chapter is trying to tell me? Once you have the big picture, our second tip is to focus on mastering the core concepts. In physics, everything builds on a few fundamental ideas. Think of them as the primary colors of the art world. Red, yellow, blue. If you understand them, you can mix them to create any other color. In physics, the primary colors are force, energy, momentum, charge. Understand these and you can tackle a huge range of problems. Don't rush past the basics. The basics are the interesting stuff. Let S take energy. What is it really? Don't just memorize capacity to do work. Think about it. Energy is like a currency the universe uses to make things happen. It can be stored, potential energy, or in motion, kinetic energy. It can change forms, chemical energy, kinetic energy, heat energy, but total energy is conserved, it never disappears. Physics can often seem like a long list of equations, but the truth is, the equations are just a shorthand way of describing what's happening in the real world. Our third tip is to learn to think in pictures. Before you even write down an equation, try to visualize the situation. Draw a picture. Seriously, scientists and engineers do this all the time. They are called free body diagrams or just sketches, and they are incredibly powerful tools. If a problem is about a block sliding down a ramp, draw the block, draw arrows to represent all the forces acting on it. Gravity pulling it down, the normal force from the ramp pushing up, and friction trying to slow it down. This process of visualization does something amazing for your brain. It translates the abstract words and numbers of a problem into a concrete physical scenario. You can see the relationships between the different parts. Which way is the object moving? Which forces are helping it move and which are opposing it? A picture makes these questions much easier to answer. Let us think about projectile motion, like throwing a baseball. Don't just think about the parabolic trajectory equation. Picture the ball leaving your hand. It has a forward motion and an upward motion. Physics isn't just something that happens in a laboratory or in a textbook. It's happening right now, in the room where you are, and in everything you do. Our fourth tip is to actively look for these connections and use your daily life as your own personal physics lab. This is honestly one of the most powerful ways to make the concept stick. When you learn about friction, think about why it's hard to push a heavy box across the carpet. Think about the brakes on your bike. Think about the grip of your shoes on the pavement. These are all examples of friction at work, and seeing them in action makes the idea real and tangible. Let us say you were studying thermodynamics. The next time you make a cup of hot chocolate, pay attention. You are observing physics. You might use a microwave, which uses electromagnetic radiation to make water molecules vibrate and generate heat. You pour hot water over the cocoa powder, and heat transfers from the water to the powder through conduction and convection, dissolving it. You hold the warm mug in your hands and feel the heat transfer to your skin. If you leave it on the counter, it will slowly cool down, releasing its thermal energy into the surrounding air. The entire process is a beautiful demonstration of the laws of thermodynamics. Make it a game. When you are at the playground, look at the swings. That is a pendulum. Notice how it swings fastest at the bottom and seems to pause at the top. That is the conversion between kinetic and potential energy. Now, we can't talk about learning physics without talking about practice. So tip number 5 is simple. Do lots and lots of practice problems. There is no substitute for this. It's one thing to watch someone else solve a problem, or to read through a solution. It's a completely different thing to face a blank page and do it yourself. This is where the real learning happens. It's like learning to play a musical instrument. You can watch videos of amazing guitarists all day long, but your fingers won't learn where to go until you pick up a guitar and start practicing the chords yourself. Problems are the chords of physics. Start with the easier, example problems in your textbook. Don't just read them. Cover up the solution and try to solve it on your own first. If you get stuck, take a peek at the next step. Then try to continue on your own again. The goal isn't just to get the right answer. The goal is to understand the process, the sequence of steps, and the reasoning behind each one. Why did they use that specific equation? When you encounter a new and abstract concept in physics, it can be tough to wrap your head around it. That's where tip number 7 comes in. Use analogies. An analogy is a comparison between two things that helps explain an idea. Our brains are wired to understand new things by relating them to something we already know. Physics is full of concepts that are perfect for this. For example, trying to understand electric circuits can be tricky. The flow of electrons is invisible, and terms like voltage, current, and resistance can feel abstract. So, let's use the famous water analogy. Think of an electric circuit as a system of pipes filled with water. Voltage, like the water pressure from a pump. It's the push that makes the water move. Current, like the flow rate, how much water passes a point per second. Resistance, like a narrow section of pipe that restricts flow. A wider pipe =, low resistance, lots of water through. A skinny or clogged pipe =, high resistance, very little flow. This makes the relationships between voltage, current, and resistance, Ohm's law, more intuitive. Now tip number 8. When you face a big, scary, complex problem, don't panic. Break it down. Physicists use this every day. No one solves a massive problem all at once. They split it into manageable pieces. Does the problem involve energy and motion? Solve the energy part first to get velocity, then use that velocity in the motion part. Does it involve forces at an angle? Our 9th tip is one of the most important, not just for physics, but for all of science and life. Embrace your mistakes. You are going to make mistakes. Everybody does. I do. The most brilliant scientists in history made mistakes. A mistake is not a failure. A mistake is a discovery. It's your brain showing you something you don't quite understand yet. When you get a problem wrong, don't just get frustrated and move on. Stop and figure out why it's wrong. Did you use the wrong equation? Did you make a simple math error? Did you misunderstand a core concept? Every mistake is a learning opportunity in disguise. Analyzing your errors is one of the fastest ways to get better. It's like a detective story. You are the detective. The mystery is, what went wrong here? Trace your steps back to find the source of the error. That builds powerful problem-solving skills. It also builds resilience. Science is a process of trial and error. We form a hypothesis, we test it. Very often, the test shows our hypothesis was wrong. So there you have it. 10 tips to help you learn physics faster and more effectively. Let's quickly recap our journey. We started by understanding the importance of seeing the big picture before diving into the details. Mastering those essential core concepts. Think in pictures, drawing diagrams to turn abstract problems into concrete scenarios. We connected physics to our everyday lives. These first steps are about building a strong conceptual framework, doing practice problems to build your skills, explaining concepts out loud to find gaps, using analogies to make ideas intuitive, breaking down complex problems into smaller pieces. Embrace mistakes as valuable learning opportunities. Always stay curious. Learning physics is not a race. There is no final exam on the universe. It is a lifelong journey of exploration and wonder. These tips are not just for passing your next test. They are tools for a new way of thinking. They will help you be a better problem solver, a more critical thinker, a more observant person. They will empower you to see the underlying simplicity and elegance of the laws that govern it.